Hello my dear students, myself Dr. Nilesh Kumar Gupta. I am working as a professor in EC department at Ajay Kumar Garg Engineering College, Ghaziabad. So today I will teach you about the digital signal processor. This title I am taking from your digital signal processing subject. Its AKTU code is KEC 503 and this is my lecture number 35, and this will be my last lecture of this syllabus KEC 503. So digital signal processor. In our daily life, if we see, so everywhere in at our home, offices, or in all the conditions, we are using the digital signal processor. So in all the machines you find some processor, and nowadays all the processors are digital signal processor, because we are not using any analog processor nowadays. In your washing machine, your oven, or in any your electronic machine, okay, in every type of electronic machine that you are using in your offices, your at your home, or anywhere, you are use the digital signal processor. So these are the very important. Okay, so these are the processor like microprocessor, and the task of the digital signal processor also same, what, like your microprocessor and microcontrollers, and these are the processors. So firstly I am giving the some introduction in short of digital signal processor. A digital signal processor is a specialized microprocessor targeted at a digital signal processing applications. Unlike the conventional microprocessors that you see, what 8085, 8086, mean for general purpose application. Okay, but the advanced microprocessors such as RISC, like reduced instruction set computer processor or complex instruction set computer processor, CISC, may use some of the techniques adopted in programmable digital signal processor. So generally in the some microprocessor like 8085, 8086, we are using for general purpose application, but digital signal processor are programmable processor. These are different, and you can use for several applications in your communication or in your digital signal processing applications. So PDSP means programmable digital signal processor, especially required for DSP application. It means digital signal processing applications. PDSP, it means programmable DSP, it means programmable digital signal processor, especially required for DSP applications, and it has the advantage over the conventional microprocessor because this is also microprocessor. Digital signal processors are also microprocessors, but these are the programmable microprocessors and containing more number of applications. Okay, so PDSP has an advantage over the conventional processor in terms of low power requirement, cost, and real time input output capability, and so on. So in number of terms, these are having the some advantages over the conventional microprocessors. So low power requirement is very important, because generally nowadays we are trying to design low power electronic devices. It's a very important technical challenge for us nowadays. So it's a very important characteristics or advantages of our nowadays digital signal processor, or you can say programmable digital signal processor. What? Low power requirement. Cost, obviously cost will be less, real time input output capability, and so on. There are so many advantages of digital signal processors are having over the conventional microprocessor. Now features. What are the silent features of digital signal processor? Like modified bus structure and memory access scheme, multiplier and accumulator unit. So this is the microprocessor. So accumulator, register, data bus, address bus, flags, interrupts. So these are the common here. The same function you will find. The concept is same, but some programming part is there. Some advanced versions are there that you can use in your real practical life in several applications. Okay. So these are the features like multiple access memory, like multi-ported memory. Okay. Now very long instruction word architecture, VLIW, pipelining, spatial addressing modes. Okay. On chip peripherals, on chip memory. So these are the some silent features of digital signal processor. Now some example of digital signal processor. So there are so many digital signal processors are available in the market nowadays. Okay. So like under the analog devices. So analog devices earlier we used like 16-bit fixed and 32-bit floating point type microprocessors. Okay. Some examples, you know this one. Now under the AT&T category, these will be what? 16-bit fixed and 32-bit floating point type of digital signal processor. Under the Motorola also there are some DSP processors are there, like 16 or 24-bit fixed and 32-bit floating point. NEC, under the NEC also 16 or 24-bit fixed point processors are available. Texas, this is the very, very important. Texas instruments. Okay. And under this several microprocessors are available now, and generally we are referring these Texas instruments or these Texas digital signal processors. These may be 16-bit fixed, 32-bit floating point and 32-bit microprocessor are available, and Texas instruments or Texas digital signal processors are the available in market, and they capture the whole market generally. It is the single largest manufacturer of DSP chips or digital signal processor. So Texas is very, very important. Generally we are using nowadays Texas type of digital signal processor, and these instruments we are using now. Now under the Texas some digital signal processors are there, like I am taking TMS 320C5X digital signal processor, and this is the architecture of that digital signal processor. So this architecture is divided into 3 parts here. Okay. So this is our CPU part, you can say this is your CPU part. Okay. This is your memory part, you can say on chip memory part. Okay. And this is your peripheral part, you can say on chip peripherals. So this TMS 320C5X digital signal processor, and this is the architecture of this processor, and in this architecture you can see these 3 parts. First is your your CPU unit, you can say central processing unit, then on chip memory unit, and then on chip peripherals unit. Like first we can understand about the central processing unit of this digital signal processor, and this consisting of following like CALU, central arithmetic logic unit. In the diagram you can see parallel logic unit, auxiliary register arithmetic unit ARAU, memory mapped registers MMRS, program controller. Okay, these are the main parts of our CPU unit. You can see central processing unit of that processor. You can see here, like here, writing here. What? CALU, this one. Under CALU, multiplier, accumulator, ACC buffer, okay, shifters, arithmetic logic ALU, these will be under the CALU. Now program logic unit PLU, because these processors are programmable, so PLU unit is also there under the CPU. Now memory map register MMR, auxiliary register arithmetic unit ARAU. Next program controller. Okay, under this program counter, hardware stack, address generation, logic, instruction register, status control registers, these will be available under this. This is our data bus, it shows by the data bus. This is our program bus. Okay. Now for this memory control, okay, multi processing, interrupts, initialization, these will be under this CPU unit. Now second is our on chip, this one, on chip memory part. So on chip memory part in TMS 320C5X processor, this is the 16-bit microprocessor. Okay, 16-bit microprocessor, like 8085 is was the 8-bit, 8086 was the 16-bit. So this is 16-bit microprocessor, has the following on-chip memories, like program read-only memory, okay, data program dual access RAM, it means DARM, single access, it means SARM. This processor has a total address range of 224K words if you count, and 16-bit, because this is 16-bit microprocessor. And memory space is divided into following these categories, like 64K word program memory space, 64K word local data memory space, 64K word input output ports, 32K word global data memory space. So this was the under the on chip memory, like this one, that I am writing in the PPT, like program ROM, then data program SARM, DARM, then data DARM. So this is the memory part, you can say, okay, and this is divided into the some categories here. Third part of the architecture is consisting of the these peripherals. These are called on chip peripherals. Okay. So under the on chip peripheral, these are the some serial port 1, serial port 2, TDM serial port, buffered serial port, timer, host port interface, okay, and test simulation, this will be there. Now this one. So the family of TMS 320C5X processor has the same CPU structure, but the different on chip peripherals connected to their CPUs, and the following peripherals are available in the family of this digital signal processor, like clock generator, okay, hardware timer, software programmable wait state generator, parallel input output ports, host port interface HPI, serial port, BSP, it means buffered serial port, time division multiplex serial port, user maskable interrupts. So these are the some peripherals, okay, on chip peripherals that are available with this digital signal processor under the same central processing unit. So I hope the architecture of this processor is clear to everybody. Now we come on the addressing modes, because this is a microprocessor. So by writing the instructions you can understand that what should be next, and for that you should also understand the addressing modes, because by using the addressing modes you can address your task, okay. You can know your task, you can identify your task. So TM320C5X processors can address 64K words of program memory and 96K words of data memory. So 64K words of program memory and 96K words of data memory, and the following addressing modes are supported by this digital signal processor, like direct addressing, like memory mapped register addressing MMR, immediate addressing, like you know the most of the addressing modes you know, indirect addressing, dedicated register addressing, circular addressing. Circular addressing is the new thing here, okay, that I will tell you in this lecture. Now in the direct addressing, what is the meaning of direct addressing? So in direct addressing, the data memory used with C5X processors is split into 512 pages, each of 128 words long, okay. And in this mode of this processor, only lower order 7 bits of the address are specified in the instruction. Whenever you write the instruction, so the lower order 7 bits of the address are specified in the instruction. Remaining 9 bits are taken from the data memory page pointer DP, because it is 16 bit, okay, 16 bit microprocessor. So 7 bit used for the lower 7 bits used for the instruction. You can say whenever you write the instruction, it is available in the instruction, and upper 9 bits are taken from the data memory page pointer. So this is your direct addressing mode. Direct you can address with the help of your instruction. Now memory mapped register addressing mode. In this memory mapped register addressing mode, what? It can be modified without affecting the current data page pointer value. This addressing mode is similar to direct addressing mode. It is similar here, but specified to the memory here, memory address you can say, except that the 9 MSBs of the address are forced to 0 instead of being loaded with the contents of DP. So this is the difference in MMR addressing modes than direct addressing, and remaining things are similar as a direct addressing modes. Now immediate addressing mode. What is the meaning of immediate addressing modes? So immediate addressing modes can be used to load either a 16 bit constant or a constant of length 13, 9 or 7. Accordingly, it is referred to as long immediate or short immediate addressing modes, and this mode is indicated by the symbol of this hashtag. So यदि hashtag symbol तुम्हें दिखता है, it means you are using the immediate addressing modes in that digital signal processor. Like you can take the example here, like add hashtag 56H adds 56H to ACC. Now we come on indirect addressing mode. In the indirect addressing mode, the ARs like from AR0 to AR7 8 bit are used for accessing the data using indirect addressing modes in the indirect out of 8 ARs. Okay, 0 to 7 it means 8 ARs. The one which is currently used for accessing data is denoted by register ARP. The content of ARP can be temporarily stored in ARB registers, buffer register you can say, and the indirect addressing modes of C5X permits the AR used for the addressing to be updated automatically either after or before the operand is fetched. Operand opcode, you know, it is the part of your instruction format. However, if required, the content of AR can be incremented or decremented by any 8-bit constant using SBRK and ADRK instructions. These are some instructions that you will find in this digital signal processor. These processors are same, okay, like your microprocessors. The concept is same, but some programming is there in these microprocessor, because these are the programmable digital signal processor. Now, dedicated register addressing, what is this? This addressing mode operates like the long immediate addressing mode. What are the merits? The advantage of this mode is that the address of the block of memory to be acted upon can be exchanged during the execution of the program. For example, like I am writing here, BLDD BMAR DAT data 100 DP is equal to 0, page pointer is 0. The meaning of this, what? If block move address register, that is BMAR, this one, contains the value of 200H, then the content of data memory location 200H is copied as it is to the data memory location 100 on the current data page. Okay. So, this is the meaning of this instruction. So, you can understand, and another several examples are available for this, by which you can understand this one. Last is our circular addressing mode. In DSP you study about the circular convolution, circular correlation, whenever you perform the DFT, discrete Fourier transform. This is also a Fourier transform, and it is a Fourier transform for discrete time signal of finite length. So, if finite length for discrete time signal, that is also periodic, then always you have to use the word of circular everywhere. If you are doing the time shifting, that will be circular time shift. If you are doing frequency shifting, that will be circular frequency shift. If you are doing the convolution, that will be circular convolution. Correlation, circular, everywhere you find circular word. But it is possible for only and only for finite length discrete time sequences that also possess the periodic property. So, similarly here circular addressing mode. So, algorithms such as convolution, correlation and FIR, finite impulse response filter, use the circular buffers, like that concept. In memory to implement a sliding window which contains the most recent data to be processed. The following are the 5 MMRs, okay, memory map registers, that control the circular buffer operation, like CBS R1. This is the circular buffer 1 start register. Similarly, CBS R2 circular buffer 2 start register. Then CBER1, CBER2. CBS means circular buffer start register. S means start. Okay. E means end. So, this is CBER1, it means circular buffer 1 end register. CBER2 circular buffer 2 end register. CBCR means circular buffer control register. So these are the some MMRs, 5 MMRs under the that control the circular buffer operation in this circular addressing modes. These are the very simple, and the concept only in for discrete, finite length, periodic sequences or signals. Now, add bits CB, CR enables and disables the circular buffer operation. To define the circular buffer, the start and end addresses are loaded into the corresponding buffer registers, like in previous example. First, next, a value between the start and end register for the circular buffer is loaded into AR, auxiliary registers. The corresponding circular buffer enables bits in the CBCR should be set. Okay. So this was about the our what circular addressing mode in digital signal processor. So there are so many another things for digital signal processor, okay, but in your syllabus these are the important title, and I am giving the short introduction of the digital signal processor. So this is the my last lecture of digital signal processing subject. The digital signal processing subject is very important subject of signal processing. You are doing the signal processing in digital domain, and everywhere, every time you are dealing only and only discrete time signal, and you are analyzing, you are synthesizing, you are dealing only and only with discrete time signal. And this is very important paper, and mathematically you can represent everything here. Generally the filters, digital filters, the concept of digital filter like IIR and FIR. You are having two types of digital filter, IIR and FIR. And these filters are very important for digital signal processing task. These filters are very important. So in this subject you can study about its realization, its designing, its another characteristics, the techniques and so on. And by using these filter, the task of signal processing is possible in your communication. So this subject is very important. All the best to all of you. Study this subject carefully, and all the best. Goodbye.